Welcome, everybody. We're going to be working on our Unit 4 exercises here today, but I did want to do just a little bit of preliminary talking about this little entry I have here in Unit 4 about different Python coding environments. I know that I have some of this is already embedded in some of the lecture videos, but I do want to introduce us here today to a really important product called the Jupyter Notebook. For many of those working in particularly the data analytics and data science areas and artificial intelligence, the Jupyter Notebook is often considered kind of like the de facto product. It is a browser-based IDE, which I mentioned just a little while ago. It is not the only option for doing notebook files, and to just very briefly explain what notebook files are, it's a combination of writing Python code and saving your output. And then you can combine that with other things like plain text, which we call markdown in those environments, and basically create a document that combines code, output, and explanation. Which is, data scientists tend to use this a lot because they can show their logic, show the results, and then talk about it at the same time. For whatever reason in that field, it is the preeminent tool. It does create a different file type. It's not going to be a .py file that we're creating. We're going to be creating, I think it's like IPYNB file extensions, which stands for IPython Notebooks, which is an intermingling of all those things. If you do not want to code in the Jupyter Notebook, it's not an obligation, by the way. Feel free to do this coding work inside of Spider or whatever IDE you're using and just save it as a regular Python file. It will work just fine. But I'm going to demonstrate the product so you can see and learn about it. This does become an important product as we move forward. I will also just kind of add the little caveat that within the last year, I've kind of switched from doing most of my Python notebooks outside of the Jupyter environment. I've been really liking the Visual Studio Code program better for doing Python notebooks than the Jupyter Notebook because it's a regular IDE and not a browser-based IDE. And one of my biggest beefs with the Jupyter Notebook IDE is where it places you when you launch. There's a couple different ways to launch the Jupyter Notebook. The one is to use the Anaconda Navigator and just hit launch, which is how I launched it today. But I often find this environment kind of cumbersome, real frankly, so I usually skip it. But I am running it in the background right now, just in case you guys are curious. The other way to launch it, of course, is just go to your start menu. And if you installed the Anaconda distro, which I recommended at the beginning of the course, the Jupyter Notebook just comes up in your start menu. If you didn't use the Anaconda distro and you downloaded Python libraries in your own IDE, Jupyter Notebook is available as free open source software out on the web. So you can just Google it and find it and download it and install it. That's absolutely fine. It doesn't matter how you launch it. When you do launch it, it will come up in a browser tab. So this is what happens when you launch it. It will drop you in your root folder, which is not your C drive on Windows. It's your root user folder. And there's ways to kind of overcome this. But as I was mentioning prior to this recording happening, that I tend to not use the product because I don't like that it forces me into my documents or my user folder to store my stuff. I do not find that that's not where I normally store things, right? And if you're not sure what I'm talking about, what I mean here is that if you go into your hard drive in Windows, go to your users folder, and then your particular user account, this is where it puts you. How often are you directly storing files here? Well, you are, but usually you don't do it from this level, right? You got a bunch of dot files in here, and you got notice your desktop, your documents, your downloads, and all that stuff are all accessible here, right? So in principle, most users should put their stuff here and it's fine. Most of my Python notebooks, you see, I just put them in the root here just because I'm demonstrating Jupyter Notebook, but I tend not to use this product because of this fact. And it's one of the reasons why I switched to Visual Studio Code to do the same work. Now, one thing I will show you really quickly, here's Visual Studio Code running with answers to the homework that we're about to do, right? And what I want you to notice is in Visual Studio Code that we develop these little code windows, and then we run the program, and then you'll see the output here. And right now it's asking me to trust this environment in this folder. So now it's trusted. And what that allows me to do then is, it's not finding my implementation of Python because I changed it since the last time I ran it. But once you have Python up and running in here and you have a Python environment attached, you get a little play button to run the code. All right, so we're not focusing on that product for today though. What we are focusing on is the Jupyter Notebook. So when you get into this interface and it launches on your screen, and this is like what you land in your file folder, which is really kind of weird, right? So what you'll want to do to get started is to hit the new button up here, and then you can run this. And now for some of you, like if you've done Python coding before, especially if you've created virtual Python environments, which professional Python programmers do all the time, you might have multiple versions of Python listed here. If you're like this implementation that I have, and I want to remind you, when we started the semester, what I did is I blew away all my Python stuff and then reinstalled it from scratch on purpose because I wanted to have the newer libraries installed. And so you should really only have one thing here, and it should be Python 3. And then what we're really doing here is we're telling this environment that we're attaching to this particular collection of Python libraries that are going to run our code. So now, if you're wondering, why do you get a choice? Because when you're a professional programmer, sometimes you write Python code for legacy things. Like Python 2 is still out there in operation, and there's different versions of Python. Or if I'm doing something that's highly experimental and might crash or run into an infinite loop, right? I might use a virtual Python environment. So how that works is I take my Python environment, I clone it, and then I attach to the clone so that that doesn't get polluted back into the operating system where I'm using regular Python to run programs. You know what I mean? So, okay, that's a little bit farther down the road. When you get to advanced levels of Python, that's a really important consideration, right? Is those virtual environments. All right, so when we land inside the product, okay, it's like, oh, okay, what's so special about this? You know, and I'm gonna give you critiques about the environment as we're working on it. First of all, I like dark mode in an IDE. And if you're really enterprising, there are ways to turn Jupyter Notebook into dark mode, but I'm gonna let you research that on your own and figure it out, right? I'm not gonna demo it here, but I'm just gonna go with what's here. The window that I have up on the screen right now, this is a coding window. And just for example, I'm gonna type in here, you know, one of our standard Python commands, and you know what, I'll zoom in just ever so slightly here. And I'll just do a print command, and we'll do our standard hello, whatever program. And then you'll notice that I'm in this box. This box is currently highlighted. Notice it's got a blue bar here on the side, right? And then up here in the toolbar, if this is the active box, which I know from the blue bar, I can hit the play button and my code will execute. And notice what it does is it looks at the code window, it executes the code, it puts the output right there with the code. Okay, so the code window is there. I tried what I tried. I see the output as a result. If I don't like what I tried, I can go back here and I can say, hello, Racine, right? And I can run that again. And notice how it updates. Right? So it's editable, right? I will have you notice that there's all these little tools here on the side. So if I want to duplicate one of these cells, so each one of these coding boxes is called a cell technically. So I can duplicate one if I want to try something different with it, not destroy the original. That's a thing you can do. You have these other buttons for moving it up in the document or moving it down in the document or adding cells above or below or just deleting the cell altogether. That's right built into the cell. Pretty intuitive, but you know, just check it out. I also want you to notice that every time I work a cell, that it gets numbered. So remember, I had the first cell and I did the thing, and then I changed it, and then it renumbered it because now technically it's the second cell. I didn't keep the first one. I overwrote the first one, but it numbers them so you have like reference points. Like look at cell number 5, you know, that kind of thing. All right. But inside these windows, we're going to start to do our homework. And I do have the homework document pulled up, so I do want to focus on that because there's a lot of coding in this unit, right? In fact, I'm not sure we're going to finish it all here today. We'll try, but what I will tell you is I do have all the solutions fully recorded if you want to like help with all the answers. The trick with these exercises now is we're getting into the course now where you guys kind of know how to code. So I'm giving you a little bit more volume of work each week to code through. And I hope you don't hate me for it, but it does really improve your skills. And hopefully it's not as daunting as you might think it is. The first few exercises are multiple parts. So you'll notice that like 4.1 has an A, B, C, D, and E, and those are all separate exercises, right? I will show you how to accomplish these, but it says, write programs with loops that compute, and then we just go through the process, the sum of all even numbers between 2 and 100 inclusive. All right, so I'm going to start like doing these one at a time here. I do kind of have some of this captured as comments from previous iterations. So in my next cell here, I'm going to put in the description. So this is exercise 4.1 part A, and in the form of a comment, right? I can drop that information in just like I do in a regular Python program. That's not executing code, right? It's got the pound sign at the beginning, so it's a comment. And so we're going to write a loop now that's going to do the sum of all even numbers between 2 and 100 inclusive. So here's one little thing that I do in a lot of these is I often will create a variable just to hold the total because we're going to create a sum. I'm just pre-creating it and storing the value of 0. And if you want an explanation to go with it, this is how I explained it last time. I just said we'll store the sum as it's calculated, and then we will print it, right? Now, here's the weird thing, and I'm going to put this in as a comment. Technically, you do not need to do this step. I don't need to pre-declare my variable, right? And I'm going to say that, meaning I do not need to pre-declare the variable. So then your question is, so then why did you? And the answer is habit, real frankly, because I learned in other languages. And so I feel more comfortable if I'm going to use a variable, I pre-declare it and set a value in it. Because eventually I'm going to print it out. And if my loop's got a problem and I didn't pre-declare the variable, then the loop, the output will fail too. So it kind of gets that way. So if like I run my loop and the answer is 0, I know my loop didn't work. That's the point. Right. So I could technically omit this step, and I'm just like letting you know that I have the habit of doing it because that's kind of how I learned. Not that it's necessarily right. I think modern day Python programmers would probably skip it. So here comes our first loop. And we're going to go with for loops for most of the stuff that we're starting with, because truth be told, most programmers, when they learn how to do loops, ultimately lean really heavily towards for loops as a preferred loop structure. Now, as we kind of did in the Kahoot, right, we learned how to do this like I, right? And we talked about, so why do we use the letter I as a variable in the loop? Because it stems from mathematics, and in mathematics, we use I to represent index, to represent the fact that we're keeping track of things as we're going through a loop, or repeating something. And then we're going to run I in a range. So here's the range function, which basically takes typically 2 parameters, the starting and ending value for I. We can also have a third parameter, which is the increment amount. Normally at range would increment manually 1 by 1. This wants me to go calculate the sum of all even numbers between 2 and 100. Okay, so we're starting out with a 3 parameter list right off the bat, right? So for example, in like the Kahoot when we were doing it, we would just get it to try to print, we would say I in range 1 to 10, and then we realized that it never reaches the 10, right? So you always have to go 1 beyond. So if I'm going to do all the even numbers between 2 and 100 inclusive, what's my first number in the range? 2. So I'm going to start with the number 2. And then I want to go up through 100 and include that. So where does my range end? Well, you shouldn't say 100. You should say it's got to go beyond it by at least 1. So I'm going to go up to 101. We'll never reach it, right? And then the third parameter is how much I will increment each time. If I leave this blank, it'll count 2, 3, 4, 5, 6, 7. If I add a 2 here, meaning I'm counting by 2s, they'll go 2, 4, 6, 8. That's all the even numbers, right? And then all I have to do once I'm inside the loop, and right, you do have to put the colon here, right, is I just want to increment total by I each time. So total would equal total plus I. That's one way to do it. Or what I would prefer that you guys start getting used to is you do plus equals I. So I'm adding I back into total each time. Right. And then ultimately, I'm just going to do an output statement, at the bottom here, and I'm just going to paste that in. That's going to come back out to the margin though, right? And then I'm going to do it like this. And, and this is old code, so I wasn't using F string back then. So let's convert it to F string. So we'll say, that's a really easy conversion, by the way. Be nice and put period in there, right? So if I run this, and I'm going to run it really quick just to show you what the answer is, right? And I know that's the correct answer. How do I know that? Okay, I've gone through the trouble, and this is kind of like a weird thing to kind of admit, but whenever you're doing programming, right, you always have to have a calculator or a spreadsheet sitting next to you, because I can come into a product like Excel to verify that my stuff is correct, right? And so this is probably more for data people than it is for web people. But if I make a list of like even numbers, right, I'm setting up a pattern here in Excel of even numbers, I can take that pattern and I can extend it down to 100. I think I went a little too far there, right? And now I have all those numbers are highlighted, and look at the sum down here in my toolbar, right, without even running a formula. That tells me that the sum is 2550. Otherwise, you could sit there with the calculator and go 2 plus 4 plus 6 plus 8. If you want, go for it, pencil and paper. But you have to have some way to verify that when you're writing your code, and I say this a lot, right, that your math is correct. So I use the spreadsheet. I think it's the fastest way to do it. So I know that number is correct. Here's a little tip I might give you as well, though. Like, if you want to see the totals increment each time, you could actually put inside the loop, print total. So every time it goes through the loop, and I think this is really handy, at least when you're first learning how to do this stuff, that you run it like that, and you'll see that, 2 plus 4 is 6. And then you can just start counting up, right? It's starting to sum all the numbers together, and it just keeps adding to the total so you can see it. Now that does get a little obnoxious, right? Because it creates a lot of output content. So you can do this, comment that out. But that's a trick that programmers will use. You're running a loop. You want to see what's happening inside the loop. You're not taking it on faith. You can put a print statement inside there and print out your variables and see where you're at. Really simple as that. So I'm going to run it without that. I think that output is a little bit more concise. So that's 4.1 part A. All right, let's move on to the next one. So now I have a new coding little cell here, as they call it, and I have the instructions for part B. You see I'm trying to make it look a little nicer now. Yes, Ray. Yeah, you just hit the play button. But you do have to make sure that the cell you want to run is highlighted, right? So like right now, this one is highlighted. So if I hit run, that's the one that's going to run. So that's our instructions. It's sum of all squares between 1 and 100 inclusive. All right, that's a hairy one. What the heck does that even mean, right? The sum of all squares. Well, if I count, if I take 1 and square it, what's 1 squared? 1 times 1 is 1. It's 2 squared? 4. What's 3 squared? 9, right? Okay, and you can figure out really quickly, those numbers get hairy, right? Once again, you can double check your numbers in the spreadsheet if you want. But I'm going to set up a total variable, once again, optional, right? You don't really need to do that. And then you can run a for loop for I in range, and I'm going to go from 1. And once again, we want to go all the way up to 100, so we have to go 1 beyond it. So we got to go to 101, put in our colon, and then what's our math? It's very similar, really. So here we're going to plus equals to total, whatever I is squared. That's it. That's the code right there, folks. And once again, if you want to watch it increment, put in a print statement with the variable that you're changing. In fact, we could just run this loop right now and notice, yeah, 100 times it kept squaring the number, and look how that number grows really quickly. Also notice how fast Python processed that, really, really fast, right? So once again, we call that an optional part of this. And then normally what we would do is we would have an output statement that I would throw here at the bottom. Come back to the margin. And once again, I'll switch just to F string approach, right? And you can tell I was working with like legacy code here. Let's put it in curly brackets, throw in a period there, and then run it. And there you go. Okay, so that was part B. Here comes part C. Part C says all the powers of 2 from 2 to the 0 power up to 2 to the 20th power. That's kind of a weird one. And you might not conceptualize this initially in how to complete it. So this is what is intended. We're going to do an I in range command again. And what 2 is going to, the number that we're figuring out the powers of is 2. So that's not going to change. What's going to change is the powers of 2. So this is the exponent that we're changing. And we want to start at the exponent of 0 and go up to 20. So we're going to take it up to 21. We'll never reach 21. Right? And then on this one, I'm going to show all the powers, right? And it doesn't want the sum of them. It wants to see them. So the print statement's just going to happen right here. I did it with an F string. So I did it like this. Notice 2 star star to the I power. Right? That's just the text of it, not the math of it. And then after I have the word is, then I actually do the math of it. See the cleverness of that? So I can tell you which power it is and then what the value of it is. So watch the runtime on this. I know you guys are copying my code. I will go back to the code in a second. But 2 to the 0 is 1. 2 to the first is 2, et cetera, et cetera, et cetera. So you can see what it is. And you can see how exponentially quick it grows. But these are powers of 2. And by the way, IT students, right, like you ever do like computer science study, back in my day, they used to hammer these powers of 2s and binary numbers and conversions. But like 2, 4, 6, 8, 16, 32, 64, 128, 256, 5, 12, 10, 24, 20, 48, et cetera, et cetera. I hate to admit that I have these memorized, I think all the way up to this number, right? And then maybe even higher, right? But that's like why when you buy like computer memory, right? They kind of like fudge it a little bit because really, you know, a megabyte is 1024 kilobytes and, you know, that thing. But all right, once again, if you need verification on code there, you could honestly have just done print and just done this calculation and that would work, right? And you wouldn't even have to put it in curly brackets. You could just say print and put this part here in the parentheses and it would give you the right answer. I just like to label everything. That's me. Moving on to the next one. This is part D. So here comes my comments on that. The sum of all odd numbers between A and B inclusive, where A and B are inputs. All right, let's do some parameters here though. And first, let's fix the ASCII art. So this goes all the way across, right? We're gonna go down that road. Let's make it look complete. And then we'll start to do our logic here. Now they did ask for prompts, right? So A and B are inputs from the user. We're gonna assume that we're working with integers, right? And so we're converting to int. So I'm just calling them A and B. That's what I'm capturing. And then here's the logic. All right, so I captured this as a comment, you know, and I just want you to think about it, right? The sum of all odd numbers between A and B. So in other words, what I'm expecting is somebody to type in the number 1 and type in the number 10, and then I'm going to find all the odd numbers in between that. So 1, 3, 5, 7, 9, and add those all together. But what if the person types in 10 and then 1? Okay. That's not going to work, is it? Okay. The other thing is, if I want them, if I'm doing the sums of all the odd numbers, I want to, like, if they typed in A as a 2, I don't want to start doing my math with 2. And so I'm going to add 1 to A to turn it into the next odd number. You see the logic here? You might not see it. So that's okay. Right? I'm just telling you, the reason I'm doing that is to allow for it to adjust things. Okay, so here's how I deal with that problem. I'm going to write an if statement, and I'm going to say if A mod 2 is equivalent to 0, we learned this during the Kahoot, what am I checking for? Whether it's even or odd. So if I divide a number by 2 and the remainder is 0, it's an even number. So then I'm going to convert that even number. I'm going to come up with a variable called num1 to do that. I could have used A, I guess. I'm going to say A plus 1. Okay. Otherwise, I'm going to make num1 equal to A. So this is going to be the starting part of my range is really what I'm doing here. So num1 is going to become the starting part of my range. From here, once I've adjusted for the first number being even or odd, now I'm going to use a loop to do the rest of it, right? To do the other part of it. And so once again, I'm going to set up a total variable equal to 0. And then I'm going to go like this. For I in range, and I know the starting part of my range is num1, whatever I adjusted it to be. Either I didn't adjust it or I did adjust it. And that, you know, if they typed in an odd number to begin with, we're okay. But then the second parameter, we're going up to what? We're going up to the second number, which is B, but we have to go one beyond it, which is, so the second part of the range is B plus 1. So it dynamically adjusts right inside the range command. And then we want to skip every other number, so we're going to count by 2s. See the cleverness of that? And it takes a little while to kind of build up to it, but there it is. Here's, now when we're inside the loop, we're just going to be incrementing whatever I is currently, which is going to be the next odd number, is going to get added to the total. Now, if you're wondering before, like, why was I doing the totals equal 0? Wait, in this document, I already had variables called total up above. And if I didn't reset this to 0 for this cell, it's going to pick up the total from the previous cell here. So your variables from one cell to the next, they're all part of the same document. They retain their value. That's the why, right? So that, you know, so if you were doing it standalone in Spider, doesn't matter. So there's the loop that does the calculation. And then ultimately, we just want to put it back up on the screen. And here is my output statement. Got a little F string going there. And then I'm verbose with the output. I say the total of the total, I really should probably say the sum of the odd numbers from A to B. Yeah, let's fix that. Let's say the sum of the odd numbers from A to B is, and then it'll show you the total. Let's run it really quick. I'm going to use some like really simple numbers, right? So notice how the prompts are different here too. Gives you like a box, right? And so I'm going to put in the number 1, press enter. Then I'm going to put in the number 10. I'm going to press enter. And then there's the output. Okay. So that one in its entirety, right? Inputs, if statement, the loop, and the output. Moving on to part E, folks. Here's part E. The sum of all odd digits of an input. For example, if the input is 3, 2, 6, 7, 7, the sum would be 3 plus 7 plus 7 plus 17. All right. So think about this. If I'm having a person input this and I want to extract individual digits, I do not want to convert what they're putting in at the prompt to a number right away. I want to leave it as text. So my prompt would be like this, just a straight input, understanding the fact that I'm capturing a string in numeric format, but I'm capturing a string. Then we're going to go character by character. And we talked about how to like kind of tunnel in and find each character here, right? We're going to go using the index values, starting with 0. We're going to go character by character, converting it to an integer if it's an odd digit, and then add it to the total. That's the logic behind it. So once again, I'm going to clear total, setting it to 0. And then we're going to do basically what I call our first for each command, even though in Python we don't call it for each, but that's what it is in other languages, which will automatically traverse the structure. So think about this, right? A string is a collection of individual characters. Each character has its own index value. So that's a data structure. It's a pre-built structure, collection of values. The for loop can traverse this automatically. So I can say for ch, representing character, that could be anything. Ch, you can call it spam if you want, right? Whatever you want to call it. So for each character in digits, which is a data structure, it's a string. That's all. There's no range command here. This will automatically traverse every character. That's the point. We're going to go through, and then we're going to do this logic. First, we're going to set up a new variable called n, and we're going to take the character that we're sending in, right? So as it traverses digits, one character at a time, each thing it traverses goes into this variable called ch. I'm going to take ch, convert it to an integer, and drop it into the variable called n, and now I can do math with it. So now I'm going to say if n mod 2 is equivalent to 1, meaning it's odd, right? 0 would be even, but if it's equivalent to 1, it's odd. Then I'm going to add to the total whatever the value of n is currently. It's an odd number, we add it to the total. And then and this I might say is optional, but I'm going to include this here inside my if statement. So once it hits a number, I can see what number is being added and what the current total is as it runs. So if I type in, like, what was their example, 32677, it'll say 3 and the total, 7 and the total, 7 and the total, using the previous example. And then we probably, doesn't hurt to have additional verbose output at the end, and I did this. The total of the odd digits in digits is total. So I'm going to go ahead and give this a run. And I know you guys are busily typing it in, so if it pops off the screen. So they want me to enter an integer. I'll use the example that they have, but this is the number they use. This is the example, 32677. So 3 plus 7 plus 7 is 17, right? There's the output. And then, of course, really you should try it with a significantly larger number. Okay, now I'm being ridiculous about this, but you guys check out that number I just typed in. How many characters it has? That's like, I don't know, the distance from here to like forever, basically. But it does it. Doesn't care. See how fast it did it too? That number. It processed that number that quickly. Crazy. But it wasn't really treating it as a number. I want you to think about that. It was treating it as a string and then only looking at the characters it needed. So, of course, it went really fast. Pretty interesting to traverse that structure. All right, so that was exercise 4.1. And 4.2, I'm going to actually do this insert cell above. Just going to add that there. Just want to show you that you can do that. 4.2a says read the first input value from the user. And I guess I should probably throw in I'm just copying some code from up here. And really what's going on is I don't have the full exercise 4 representation. And there's a way to word wrap this. I don't want to look it up right now. So I'm just doing it like this. It says write programs that read a sequence of integer inputs and then print the smallest and largest. And this is the breakdown of all the things that we're doing. So the first one, so we're going to read a sequence of integer inputs, so more than one input, right? And here's where it kind of gets interesting, right? So if I'm prompting a user to enter a series of integers, I want you to think about this. They're going to do that over and over again. It doesn't tell them how many to enter. Just telling them to enter a series of numbers. So for starters, we're going to prompt them. And what I say in the way that I handled this here, oh, I already have it on screen. So read the first input value from the user. So we're going to prompt them like so, right? And once again, I want you to notice I'm not converting this to a number yet. Okay. A couple of reasons for this, and I just want you to think about it a little bit. What if they type in a letter? Okay, well, I got to deal with that. Okay, so here's what I said as comments last time regarding this issue. So like, this is how you start thinking when you're a programmer, right? It says, if the first value was an integer, process it in the remaining input value. So we're going to keep prompting. Otherwise, an appropriate error message is displayed. So here's my logic. I'm going to say if, oops, not all caps though, thank you. If the input string, and I did a capital S there, if the input string does not equal a blank. So I type something, right? Then what are we going to do? I'm going to grab the value, that's what I'm going to call it, and then I'm going to convert to an integer whatever the input str, input string, was. And then I want you to remember that what we're trying to do with the first one here is we want to track what the smallest is and what the largest is. For the moment, smallest, new variable, is going to be the current value. That's the smallest one. And largest is also the same value. So the first time you do it, provided they type something in, assuming it's a number, right? We're not really checking for that yet. It's both the biggest and the smallest number when we start up. Here's where we get into an additional loop. And you'll notice that right now I'm inside of an if statement. Okay. And so what I typed last time, just to do the explanation here again, I have these typed out. So sometimes I get very verbose and type it all in. It says, as long as the user hasn't entered a blank line, convert the input to an integer and determine if it is the smallest or largest value. So we got the first, so this if statement here, as we started, is just getting that first value, converting it to a number. It's both the biggest and the smallest currently. But now we have to keep running, right? We have to keep doing this to match all the sequencing. So now I'm going to start a while loop. This is our first while loop, by the way. So I'm going to check this works kind of like an if statement. So I'm going to check to make sure that that's not blank, but which it's not going to be. The first time it's not going to be. You guys see where I'm going with this? So it'll run at least once. How do we know that? Because they already typed something in and it passed that check up here. But we're asking the same thing to keep this loop running. And then once we're inside that loop, we are going to here convert that value once again to a string. Now, here's what you guys are going to say. You just did that, right? Or convert the value to an integer. Okay, so it doesn't make sense to do it again because we already did it. But once we're inside the loop, we have to have a place to do it. That's why we're doing it again, right? And I could write an if statement around it, but whatever. Let's not make it that complicated. So now we're going to end up checking whatever the current value is against the new value that's typed in. So what we're going to do is we're going to say if the value is less than smallest, then the new value or smallest, the smallest number now becomes the new value. All right. Then conversely, if the value is greater than the largest value we've already captured, then largest becomes the value. Pretty simple code, actually. And then we end up re-prompting. And I want you to notice here that we're just going to repeat the same prompt we had before, but now it's inside the while loop, inside the if statement. Now, think about it. If they type nothing and just press enter, none of this would ever happen, right? So that's why we say enter an integer or a blank line to quit. So what becomes the sentinel value then that the while loop is looking for to exit? A blank line. Pretty clever, right? Okay. So what we have left to do then is just simply to display the results. For that, we want to do that also inside the if statement. So we don't, like right now, if you look at the hierarchy, the while loop is inside the if statement. I don't want to put the results of all of it inside the while loop. So I'm going to go down one more line and come back one level and put my output here. Once again, all of this is inside that if statement. So if the user types a blank line to quit right at the beginning, we're done. Nothing happens. They type something, then we start to process. Now, we are not yet dealing with this thought of like, what if they type a letter? Okay. That comes later. We'll do basically exception handling and error handling. You could write if statements around it if you really want to, but let's just assume that the user is intelligent enough to type a number right now. Normally, we would never take that on faith. So let's go ahead and run this, see how it runs. So enter an integer. So I'm going to type 1. Okay. Enter an integer, 2, 3, 4, 5, blank line. There it is. Not very dramatic because I dropped out, but it showed the prompt again. Do we have a problem? Is there a problem here? Let's see if anybody catches it. All right, here's the error in the thinking here. Because you notice I got the blank line here and it gave me the value as 5. What would happen? And I know some of you are going to think this, right? Because like here we're like comparing values, but we never even captured it. Should the prompt go here? Watch the difference. Do the same numbers. Right now I'm going to do a blank. See where the problem is here? Because the prompt came first, it still wants to do this. I just gave it a blank line. Yeah, see the flaw in the logic, right? Okay, so here's the fix. So I'm control-Zing my way back. If you want to check the value first going in, what you need to do is take this prompt, which I don't want to copy the cell. I just want to copy the text. Thank you. Okay, now where did it go? Did I just delete my cell? That's horrible. I just deleted my work. Yeah, I'm going to try to redo. I'm trying to see if I can resurrect it. Well, I have all the code here, so I can, all right. Very, very undramatic, by the way, when you blow away all your work. And thankfully, there it is. All right, so I got it back. All right, so the fix to this is to take this prompt and put it above the while loop here. Right? You guys are thinking about it. Yeah, you guys are thinking about it. All right, let's run it. So I'm going to put in 1, 2, 3, whatever. I'm not doing it in the right order. And now I'm going to do a blank and I'm scrolling so you can see the result. See the difference? I don't get that error. So you got to prompt before you go into the loop. So we're prompting the start, right? Check to see, because otherwise it could exit right away. Then we prompt before we go into the loop, adjust it to a number, set smallest or largest if applicable, and prompt again. But I have to have a way inside the loop to change or get out of the loop. And this is the sentinel value we're looking for is that blank line. All right, so that's 4.2a. 4. Oh, there is actually a way that we can kind of deal. All right, so I have a little caveat here that I didn't finish this. I'm going to add one little wrinkle to this because we have this big if, right? And then we're done, right? And here's what I did last time is I went back to the margin here and down a line. And if they end up typing nothing at the beginning, I never really felt really comfortable like saying, okay, nothing happened. Program's done, right? Because think about that. I run the program, I just hit a blank line and it just goes away. Nothing happened. Nothing came on the screen, just said type in a number and then nothing happened. So how about we just put a little thing up there that says, all right, no input values were provided, and then we exit. And then what I normally do, and I'm kind of a geek about this kind of stuff, especially with console programming, is I like to sometimes just tell a person that it's done. Right? If you're running a windowed program and you hit the X, well, you know it's complete. Right? If you're on a console program and you go back to a prompt, don't you want to know that it's complete? So case in point is, this would happen if I type nothing. Right? So that's my little demo there, and I forgot to add it before, and I apologize. You can type a whole bunch of numbers in there. So this will keep accepting numbers, and I want you to be mindful of this. We'll keep accepting numbers until it just basically chokes on it. All right. The next exercise is basically to determine, so I don't know that I have this, so I'll just say exercise 4.2b, which is, so we're going to read a series of numbers, and then we want to know the number of even numbers and the number of odd numbers. Seems pretty simple. And here's where you get clever with this stuff, right? You can start to copy from yourself when you do this, right? So like if you, hey, you have a prompt that you already use that works and looks good, hey, just repeat it, right? Notice I'm setting up two variables, an even and an odd, presetting them to 0 because we don't want to start with a count in advance of that. We're going to go into a while loop this time, and we use the same logic. While the input string does not equal a blank line, right, nothing basically, we are going to convert the value. So I could have copy pasted this code, and I probably should have, right, to avoid typing errors. Convert it to a number, and then we'll just check if the value mod 2 is equivalent to 0. We can add 1 to the count of even. Otherwise, else, odd gets a plus equals 1. Pretty simple little algorithm. And then come back one level and reprompt. Like so. And then you should probably be polite. Come back to the margin here and have an exit message. And this is using the old approach, so I'm going to get rid of that old approach and put the curly brackets in there like this. It's not that the old approach doesn't work, but at this point, the general consensus in the Python world is use F string for everything. And then they have the new T string, which I haven't mastered yet, but it includes the formatting commands built into it. So it can't be much of a stretch, but I think that's 3.14 and above. Enter an integer. Blank line. The user entered 2 even values and 3 odd values. That is correct. Moving on to exercise C. I'm trying to find like the description for C. The description for C, I'm just going to say exercise 4.2C. The description is cumulative totals. For example, if the input's 1729, it should print 1, 8, 10, 19, right? So the total as it's running, basically. So going back to that, I'm going to start with the same prompt I've been using. Keep it really simple. Set up a thing to hold the total. We'll do a while loop. Start it out the same way we've been doing it, right? Make sure it's not blank. Convert to a number. And then we'll do our processing. So the first thing we want to do is we want to say, add to our total, whatever the value is, the number that was just typed in. And then we'll do just a simple print with an F string. And we're going to say, what are we going to say here? How about the total is total? I think that's adequate. Close that parenthesis. And then we prompt again. Give them a chance to exit or add another number. Their choice. And then once again, be a geek. And I'm going to throw this in. Program complete. I think I think I probably stole that from Star Trek now that I think about it. Like people going to the holodeck and it's done, program complete. There you go. That's me being a geek. So here comes the runtime on this. So I'm using simple numbers, but you can use any large numbers you want. Go. Blank line. That's it. Should I give a total at the end? No, I just gave it above. The point is the mechanics of it more, getting used to the loops, right? For D, and I have all my descriptions are really way up here at the top. D says, oh, this is a weird one. This is definitely a weird one. So call this exercise 4.2D. This is the description. All adjacent duplicates, for example, if the input is 1, 3, 3, 4, 5, 5, 6, 6, 6, 2, it should print out 3, 5, and 6 because those were repeating with the numbers next to them. Pretty weird stuff, right? All right, so how do we logic this one out, right? We know that we have to leverage the fact that it's still a string, right? And we will do this. Same prompt. All right. But now I'm going to set up a couple of variables here to kind of help me. So I'm going to set up a variable called previous. And did you guys just lose my screen share? Online people? I'm going to pause the recording here for just a sec. Same effect. I'll just ask online people, are you seeing my code screen or are you seeing my face? No response from the online, but that's okay.
Sorry, I'm knee deep in work problems. But yeah, it was recovering. I saw your screen and everything.
Okay, good. Thank you.
Drama too.
Yeah, I'm sorry to hear that. I know how it goes. So we're going to capture whatever they typed in. We're going to put it into previous, so we're going to hold it so we can compare it to the next thing that gets typed in. And then I'm also going to set up what I call a flag variable. And we haven't used these a lot, but this is going to be a Boolean, right? And so I'm going to start out right now. I'm not going to print which number, you notice that in the description it says the program should print 3, 5, and 6. So right now I'm going to set a flag to false, and this is a Boolean, right? So I have to use capital F here to set it to false. So in other words, whatever they typed in, I haven't printed it to the screen yet, but I'm only going to print it to the screen when I switch printed to true, so I don't print it again. So in other words, if somebody types 3, 3, 3, 3, 3, 3, 3, I only want to put 3 up on the screen once. So if it's already printed, I don't need to put it up again. So I'm setting up a Boolean to keep track of that, right? Something you might not think to do, but I'm thinking of it. All right, so they typed in a number, we stored it, we set the flag to false, and then we're asking for another number right away, right? And then we'll use a little bit of logic. So watch the logic that I come up with here. I'm running an if statement. So I'm going to say if the previous number they typed in is the same as the current one, and the printed flag is set to false, then we'll do what? We'll indicate that it's a duplicate. I'm going to put that on the screen. I'm going to switch this to F string, by the way. Trying to convert all my legacy code here to the modern format, curly brackets around this. So we'll say the number 3 is a duplicate. We'll switch printed to true. So if the next number is a 3, we don't print it again. Right? Right. Okay. And then, is there an else to this? No, there's not an else to that, but there is an if. If the previous one does not equal, not dash, the input string, I want to take a different action, and I'm going to set it. So if they type in a number that isn't the previous one, I want that flag set back to false. Could I do that as an else? Do I have to do two separate if statements, or could I have done this as an else? All right. As you guys are pondering it, it's a pretty heavy question, right? And from a lot of you, the way you figure this out is you just run the code and see what happens, right? That's one way to figure it out. That's fine. But from a logical standpoint, I want you to think about this. You keep typing in the same number over and over again, right? It's gonna hit that first if statement, or is it? What if they type in 3, and the next time they type in 3, will the first if statement hit? No. Think about it. It won't hit because printed is set to true now, and both conditions have to be true because that's an and. So this has to be true, and that has to be true. So it wouldn't hit that. But if it doesn't equal the previous one, we want to set that back to false. So if we type in 5 instead, it'll flip it back to false. Otherwise, it'll just keep taking 3s all day and not do anything. See the thinking? Right. So else would not work. Okay. So if you're wondering, because I have had students in the past say that. And then every time we finish this logic process, previous is set back to whatever the current one that was typed in. You check that at the bottom, and it just keeps going. So it'll set it to the new one. It'll prompt again, and it'll run these checks. So this is all the logic right here. This is a pretty weird little program, but let's try the number they put in up above. So 1, 3, 3, 4, 5, 5. What am I doing wrong? It didn't want me to type them in like that. It wants me to do this. And I'm going to scroll down here. So 3 is a duplicate. You see that? Right? Now I'll type a 3 again. Well, it's a duplicate again, but I don't need to say it again, do I? Yeah, I don't need to, right? And this is where it gets weird. So let's go 4, 5, 5. There's a duplicate. 5, 5, 5, 5, 5. Then we'll move on 6, 7, 8, 9, 9. There's a duplicate. Blank line to quit. And we are done. You could probably orchestrate this in a more elegant way, but the point is that it's the logic part of it, and then like kind of looping through and thinking about like true, false, and conditions, and like when people are inputting things. But now you've had this like little flavor now, mind you, of both for loops and while loops. All right. From here, we move on to exercise 4.3. And I actually have this copied already, so I'm just going to come back here and I'll put this in the next box. So here's all the prompts, right? So we'll just kind of do these one at a time. So we're going to get input, and actually there's got to be more description than that here. Write programs that read a line of input as a string and print. Okay. So they don't care if it's numbers or letters or whatever, but we're assuming letters, right? Right. So then we're only going to print only uppercase letters, every second letter, the string with all vowels replaced by an underscore, pretty weird. The number of digits in the string and positions of all the vowels in the string. All really weird questions, but you can go like, why are we doing this? All right. This is all mechanical stuff, right? The loop is involved in all of these because we're traversing a string, right? The other thing that it's showing you is one of the reasons why we use this for AI work and for data analysis work is because Python very elegantly and simply, because of its looping structure, and especially the for loop able to traverse it, is really elegant at handling language problems and analyzing language and letters and words and all those things. So very, very powerful in that regard. All right, so we're going to do the first exercise here. So we're going to start with A. So I'm just going to add another cell below, and we're going to do, I guess, this. So we're going to start with, something like this. Now, we're not worried about telling them to put in a blank line to stop. The loop is traversing the string. That's, you know, the point of it. So ideally, if you want, you could put in a thing that says, you know, if it was blank, you know, run a loop and make them type in a string, but, you know, just nothing will happen at this point. So use the same technique for each character in the input string, right? So whatever they typed in, you know, character by character. If the character, and now we're going to use one of our string methods called is upper. This is a weird one, right? And notice how it's kind of in the form of a question. And what it's asking is, if the character is uppercase, it's going to return true or false. So whenever you see like an is function, they're usually true false functions. Right? So if the character is uppercase and that comes back true, then what are we going to do? We are going to print, spell it right though. And here's kind of an interesting technique. I don't know if I've demonstrated this one much. We're going to print the character, but we want to put it back on the same line. So the next time we print a character, they all stay on the same line. So I'm going to use the end parameter here, and I'm just going to say end equals an empty string. So that it's going to read it and put it back up on the string. If it's uppercase. Only if it's uppercase. Right? But if I have like you know, somebody's formal like first, middle, last name, each letter is capital at the beginning, I'll just get their 3 initials, but they're all on the same line. So the end parameter keeps it there. If you want to put a space between those characters, you can do that. So you know. So that's the if statement inside the for loop. If it's not an uppercase letter, it's just going to skip over it. Right? Yeah. Right. We're going to go back to the margin, down the line. Right. Another little thing I threw in is, well, there's an is upper function. Yeah, there's an is lower. So if the input string, and I want you to notice we're not checking each character now. If the whole input string is all lowercase, this will detect it and it'll just put up a message saying no uppercase letters. Pretty cleverly simple, right? All right, let's run it. Let me see like an example. We'll enter a string. Hickory dock. Mouse up. Go. And I have fun with it, right? Like, you know, like you see like those like WWJDs, you know, kind of thing. Come with your own acronyms here, folks. Let's put the capital letters in there. Pretty goofy, totally silly kind of stuff, though. I want you to think about this, though. Like these are like really comical almost, and like, you know, but the fact that you can write code to analyze like weird strings of text, I mean, come on, that's really cool. All right. 4.3b. And I know we're over time, so anybody who needs to go, you guys are free to go. I'm going to code all the way through this before I wrap up the video. So you guys can just bug out whenever if you need to. I'm not trying to keep you here. So let's get our prompt. We need to prompt again. If you want. You know, one thing you could do is if they prompted up here, I could just run some code down here to analyze what they typed in up there. That's totally doable too, right? But we want to display every second letter. So here's how I'm going to do that. I'm going to say if the length of the input string is greater than 1. So they typed something in. Then I'm going to run a for loop. And I'm going to say for I in range from 0, because the first character is in position 0, up to the length of the input string again. but type it all correctly, which is something my fingers seemingly do not want to do. And then we're going to go every second letter. That's how we would do that. And then we would print that letter. So we would print, so we'd print the input string, but only the current position, which is I. And then we're going to extend the print statement, and we're going to put a space in between each one of these. So this should be n equals space like that. That's how I would do it. And then okay, great. So Ray's kind of pointing out a thing here, and I was wondering if anybody would say this. Right. So normally when we do the range, we go, for example, we go from wherever we're starting at to one more than where we want to go. But if I'll put it like this, if I type in the word, I don't know, how, 3 letters, H is in position 0, O is in position 1, W is in position 2. What's the length of how? 3. It's already 1 over the index number. Isn't that clever? Yeah, there we go. But thank you for asking the question, Ray, because it got recorded into the video. So somebody's going to be wondering that exact same thing, and now we have an explanation for them. And then I just had like a little snarky closing comment here, which was basically, item is too short to display any characters, right? So run that. We'll type in, okay, hey, whatever is cool with me. Every other character. Completely useless in practical life, but who knows? Maybe you're building a crossword puzzle and want to trick people. Yeah. I don't know. Very, very goofy stuff for sure. All right, here's another weird one. Right, check each character. If it's a vowel, display an underscore instead of the character. All right. Once again, we'll start with the input string, capturing it from the user. Right. Once again, you could use the previous one if you wanted. And then we're just going to come up with this simple for loop. I'm going to dump this one all on the screen at once, just for the sake of time. So we're going to traverse the input string one character at a time. If the character, notice what I did with my, we were checking to see if it's a vowel or a consonant. Well, I saw a couple of people already finish this one, and I did have one person write an if statement that put all the consonants in there. And honestly, now that I think back on it, I think they did as a list, which is not allowed because we haven't been taught that yet. So we're just putting them in as a string. So we're doing A, E, I, O, U, upper and lowercase. Pretty simple, right? And then if the character is part of that string, then we print an underscore and we keep it on the same line. Otherwise, we print the character and move on. That's the whole algorithm. Super easy. Super duper califragilistic, whatever. And have a little fun with it, Don't use swear words for homework. Do that on your own time. But goofy little algorithms like this that just kind of powerful though too, right? When you think about this, what we're doing here. Trying to remember what the fourth one was here. The fourth one is the number of digits in the string is the instruction. So 4.3D, it's the number of digits in the string. My solution here again. So we're going to start with a prompt. Set up a counter, preset it to 0. This is count stuff, right? Then we're going to check each character. it's a digit or a number, and add it to the count. Kind of a weird little algorithm. Check out the loop for this one. So for every character in the input string, if the character is greater than or equal to 0, this is kind of a weird statement, and the character is less than or equal to 9. Okay, so do you guys notice that, first of all, I'm not converting the input string to an integer, right, or a number. And then when I check the character, I'm using greater than or less than. And I want you guys to remember that even though it's being treated as a character, remember that characters have Unicode values that are numeric that happen to be in sequence of the numbers that they are. So I can actually do this comparison. This is really kind of weird. So if it's greater than or equal to 0 and less than or equal to 9, what's the Unicode value of it? It'll know that it's a value that's a numeric value because 0 to 9 contains all the numeric values, all 10 possibilities. And if it's a number, it'll throw it in, and if not. And what I'm going to do here when I run this program is I'm going to type in a combination of letters and numbers. That's what I'm going to do. I do want to have some sort of output statement here at the end, though. And once again, I'm going to convert this to F-string format here for the modern day. Let's just retype count. Easier than trying to navigate around it. And let's go ahead and run this. Enter a string. So right, some numbers, some characters, even some special characters, right? Kind of randomly landed my hands on the keyboard. Let's press enter. It contains 10 digits. I got 1, 2, 3, 4, 5, 6, 7, 10. Correct. Good job, Python. Isn't that really cool, though? And not only am I finding the numbers in there, but I'm counting them, but I could also do math with it. Isn't that weird? So somebody can type in words, I can extract the numbers and do math with the numbers. So actually a very useful algorithm. Part E is the positions of all the vowels in the string. So 4.3E, positions of all the vowels in the string. All right, let's go and start here once again. Let's start with the prompt, if you wish. I'm going to start us out with a print statement here. Notice I'm using that end parameter. So the vowels at this, really all I'm doing is putting those words on the screen. And then I'm leaving the print prompt, if you will, at the end of that line so that I can just put it all on one line. Then I'm going to run a for loop. So here's the structure of my for loop. So I in range from 0, once again, to the length of the input string. And it works because the length is one higher than the last index number, right? Clever, clever, clever. Then we're going to check each position. Once again, for vowels, we already did that before, so we know how to do that. It's a simple way to do it. And if it's a vowel, we're going to put in place of it what? Well, we're not putting nothing in place of it. And I want you to notice this. So the input string in position I, if it's a vowel, we're going to print the index position. That's what we're printing, not the letter. And then we're going to put a space in between each one of them. So we'll have a list of all the index positions where there's a vowel. That's what we're generating here. Right? So if I run it, right, and I don't know, randomly type in a bunch of letters, some are vowels. Those are the positions where there's vowels. You can verify it, of course, if you wish. The first one occurs at position 3. Remember, position 0, 1, 2, 3. Position 4, 7. The next little demo that I'm going to do is, and once again, you guys are free to go because we're 20 minutes over, is, and I usually do a whole little spiel about this, talking about the Fibonacci sequence, which is kind of like this weird ratio, right? So you can look it up, and they have a lot of information online about it. And I'm going to click into this little example. But basically, the way that the Fibonacci sequence works is it takes numbers in a sequence and then adds the previous two numbers together to give you the next value in the sequence. So for example, first number is 0, next number is 1, right? So those are, all right, if I add those two together, I come up with 1. Then if I take 1 and 1 and add them together, I come up with 2. Then if I add 1 and 2 together, I come up with 3. And if I add 2 and 3 together, I come up with 5, et cetera, et cetera, et cetera, on into infinity, right? And you'll notice that here's the sequence: 0, 1, 1, 2, 3, 5, 8, 7, et cetera. And that goes on forever. And then when you take that and you plot it, and this is kind of interesting, and I think maybe I go here to the Wikipedia article if I remember right. What happens with those, right? So if you form the Fibonacci sequence and you put it up on a screen like this, and you put it on a chart, you notice that the first number in the sequence, the second number in the sequence, and then it goes to 2 and 3 and 5 and 8. And these are like squares. And what this ends up doing is it forms what we call the golden ratio, which is like this infinite curved shape. And people see this as very magical, right? Because this is one of these like special sequence types. There's also, when you try to analyze the formula for it, it is what we call self-referencing, right? So this is where the recursion comes in. And this mathematical pattern forms what we call the golden ratio and creates this spiral that we see forming in nature all the time automatically. I think it's really kind of fascinating, right? So once again, math describing nature, right? So this is kind of like the thing. The interesting thing is they come up with this number when they do the ratio, which is the one number relative to the next is 1.6818 times larger. And they say like people who have like beautiful faces, for example, have those ratios like built in, and that's why they're beautiful. And we perceive them as beautiful because they're built according to the golden ratio, where a lot of us have anomalies and we're a little bit off, and that person is not quite so beautiful, goofy, whatever. This is a really interesting little thing, but it is a recursive algorithm. What I'm going to do is I'm going to put this out really, really quickly. So we can actually prompt our user. This is, I forget which exercise this is. I should know this. Is it 4 point, there it is, 4.15. And they give you kind of like a little precursor on how to do it and whatever. But let's do it like this. We are going to allow the user, and maybe I should label this as 4.15. Fibonacci sequence. We allow the user to input a number to start with, by the way, which is kind of weird. Right. We start by handling this situation. So if it's like one of the first two numbers in the sequence, we just preset it manually. Right. So the first 1 and 1 that you see in the chart, we just put in. Then we add an else. And here's where we take the guide from the exercise description. We put in a fold 1 and a fold 2. This is for tracking through the thing. Then we set up our for loop. We start with the number 2 because we've already covered numbers 0 and 1, by the way. And then we go from 2 up until the number that they designated. So really what the user is inputting is how far up into the Fibonacci sequence we want to go. 13, 1000, whatever it is, right? And then we just follow the algorithm as it was designated uh, in the assignment, which is basically this. And boy, that came in a little bit off. Fix that so it runs. And then every time we do these maneuvers, without getting highly technical about how the Fibonacci sequence works, we're going to put the new, whatever the new calculated number is up on the screen with a space in between it. So we'll see like the, you know, 1, 1, 2, whatever, you know, going from 2 up and above, starting at 2. And then ultimately, we're going to display the results. That's going to happen here outside the loop and outside the if statement. And we can convert this to an F string may as well. All right. I'm going to run this, enter an integer. I'm going to use a kind of small one to start with, like 8. Oh, that wasn't an 8. Oh, I see. My numlock's turned off, so my 8 key turned into a up arrow, which repeats my last command line, right? So I'm going to type in the number 8. And so the Fibonacci number for 8 is 34, and really we need to add space there, right? So, and if I look at the sequence, it goes 0, 1, 1, right? And it climbs up from there. We're omitting the 0, 1, 1, 2 from the beginning of it. I could, you know, I suppose I could print that in there, but then the numbers that follow is what we're looking to be correct. If you want to run this again, what's kind of weird about this is you can put in some pretty large numbers, right? And it'll generate it. I just want to show you. That's pretty crazy, right? This is the Fibonacci numbers. And what was the number I typed in at the beginning? 1,234. So this is the Fibonacci sequence for 1,234 numbers. It's crazy numbers, dude. Right? Crazy. You guys notice I'm still scrolling? It's 1,000 Fibonacci numbers, and I want you to notice how big those numbers at this point are taking multiple lines, how quickly that grows to infinity. It's really bizarre. And I just want you to notice that I'm still scrolling. So this is how big the numbers we're getting at the end. Okay. I mean, this is, how many decimal places is that? It's a lot. It's a lot. Did you see how fast it did it though? Yeah, pretty insane kind of stuff here. And I think we have one more, or is, I'm trying to remember here. 18. So let's go to 18. 18 is write a program that prints a multiplication table like this. Now, what's challenging about this, right, is you type these numbers in, and then here you have like an extra space. And then eventually you get to that third column and you need to have, well, 2 extra spaces. So then you're like a 4-digit space between all the numbers, right? So this is kind of like the challenge with this exercise. And I'm going to show you how to do this with essentially 3 lines of code. Kind of crazy when you think about it. So here's a challenge, right? Putting a sequence of numbers up on the screen with a loop, probably not too hard. Like I would do like maybe space, 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 number, space, 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 number, space, 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 number, right? But I would go from 1 to 10, and then I would loop again. But the first, like printing out the first row is one loop, and then printing out the second row is a different loop. But printing out each row can be our inner loop, and printing, moving to the next row is our outer loop. So it's a loop inside of a loop to create a 2-dimensional structure. So you can use this to generate output, or you can use this if you have a table of information. You can also use this to read in information when you get to more advanced levels, but we're going to use it strictly for output at this point. So here's what this looks like. And I am going to just dump this all on the screen at the same time. and I apologize for doing that, but I'm just looking at what time it is. We're really running over here, right? So the way that this is going to work is like this. So I'm going to set up an X and a Y, right? The Y is for each row. The X is for each column, right? So really we think X's and Y's, but the inner loop is the X, the outer loop is the Y's. So for the outer loop, we're going to go from 1 to 11 because it's a multiplication table from 10 to 10. Right? So we go up to 11. So the inner one is also from 1 to 11. So for each time we do the outer loop, we come in and we do the inner loop 10 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then 2, 4, 6, 8 go up to 20, and then 3 up to 30, right? Right, okay, so you guys remember your multiplication table. Now here's some of the old formatting commands in here. So we didn't spend a lot of time looking at this stuff, but if you go back to the string chapter, chapter 2, I think it is, where they have all the string formatting commands, this is a way to put basically 4 spits, to take whatever this calculation is. So we're going to multiply our X and our Y. And then this percent sign inserts that value into this position, but it makes sure that it's 4 digits, numeric digits, where the number would be in the 4th position, 3rd position. And we'll keep it all on the same line. Now, as we run the outer loop, the first time Y is set to 1. So for 10 times, it'll be 1 times 1, 1 times 2, 1 times 3, 1 times 4, until we get all the way through the loop. So watch what happens when we do the output here. Isn't that simple and beautiful? Pretty simple and beautiful. But it also shows you why the formatting commands are kind of helpful. Now, my understanding is, and I haven't mastered this yet enough to teach it, is that the T string combines this old formatting technique with the F string approach. Instead of using the percent sign, we're using curly brackets to do it. So I can look that up, and you guys can look it up too. But that only works in Python 3.14 and above, which I don't think 3.13 supports it, but 3.14 does. And most of us are using 3.13. We did Anaconda, we're all using 3.13. But that's how you do it, using the old formatting command. And folks, that ends this video, and we are all done. But we have questions. Okay, so I'm going to record the questions. Go ahead, Ray. Oh, okay. You know, that's a good question, right? So what Ray is asking is, like, if you did the work in the Jupyter Notebook, basically, how do you turn it in? Okay. What I would like, ideally, is that you turn in this file. So let's actually, thank you for doing that, Ray, because, you know, I would just, right now, this is untitled, right? So I'm going to save it. And this is going to go into the root of my user folder here. Save notebook as, and now I can give it a name. And so what I'm going to call it is, this is unit 4 exercises, all of them, right? So it's all the exercises. And I'm going to put in a little moniker here for spring 26, so I know which semester it's from. Otherwise I forget. Right. So I'm saving it. So this would be your code file, right? Your code file, if you notice, your Jupyter Notebook keeps all the things open. So that will get stored here somewhere. Unit 4 right here. So there's the file. That file is going to be in your Windows user folder. So the way you get there is you go to C, users, find your user folder, and it'll be right here in the roots, right? Not a great place to store it. You can put it in a different folder. That's where I decided to put mine. It's your choice where you put yours. So there's mine. So that's your code file. So you turn in the code file. Ideally, and I asked for this in the assignment, I still want screenshots. So if you could please do exercise by exercise screenshots, I appreciate that. If you don't, I kind of let the notebook slide because the output's in them and I can open them. But from a grading perspective, I prefer the screenshots. But thank you for mentioning that, Ray. All right, let's now call it a video. So this class is complete, and I'll see you guys all next week.